Example 4. It's claimed that volleyball players, so this I didn't color code it. It's claimed that volleyball players have an average height of 210 centimeters with a standard deviation of 13 centimeters. A team of 16 volleyball players has a mean height of 206. Is that enough evidence to reject the claim with a confidence of 90%? So obviously, or not necessarily obviously, but this part is the experiment. This part over here is the question. And this part over here is the claim. So let's go and actually answer this thing. So the null hypothesis is that the mean is 210. We think that, so our experimental mean was 206. So the mean was 210. Our experiment was 206. So we're going to be calculating this probability over here. So our alternative, it's not that it's less than 206. We say that it's less than 210. We want a confidence of 90%, so the alpha is 10%. Our new and improved standard deviation is going to be the standard deviation divided by the square root of n. So the standard deviation was 13, and we took 16 people. So it's going to be 13 over root 16. So it's 13 on 4, which is going to be 3.25. So what we want is we want the probability that the mean is less than 206. We're going to have to have a z-score situation. So the z-score is going to be x minus mu over sigma, which is going to be 206 minus 210 over new and improved sigma, which is going to be 3.25. Which is equal to minus 1.23. So then going back to there, we have the probability that's going to be equal to the probability that z is less than negative 1.23, which is going to be 10.93, which is going to be 10.93%. Is it less than the alpha? It's close, but it's not quite, right? And close, what does it count in? Horseshoes, hand grenades. It's not less than the alpha. So therefore, we cannot reject the claim. Which means we actually have to accept it. So we accept that. So whoever claimed it said that volleyball players are 210, they are. Well, at least they're probably not, but we don't have enough evidence to say otherwise. At least not enough evidence to be 90% confident that the claim is wrong. Slurm Incorporated claims that 80% of the people alive today enjoy Slurm. It's a delicious drink. A study of 50 people, that says 50. A study of 50 people finds that 37 of them enjoy Slurm. Can we reject this claim with a confidence of 85%? So, this one's a little bit different, right? Because what happens here is this is going to be a binomial distribution. And so what we're going to do, because we're not given a standard deviation, we're not really given a mean, we're sort of given a mean, but not for the thing. So we're going to have to do some binomial approximation stuff. So first we're going to say, can we approximate? So to figure out if we could approximate, we need to figure out, well, so we need, we should write down what is success NPQ. So success is going to be enjoys Slurm. We have 50 trials, so 50 people tried the Slurm. The probability of success, we're going to assume that Slurm Incorporated is telling the truth. We always accept the company's claim when we're doing these calculations at first, until we can prove otherwise. So NP is 50 times 0.8, which is 40. NQ is 50 times 0.2, which is 10. Are they both bigger than 5? They are both bigger than 5. So we can do the approximation. So the approximation is that the mean is going to be NP. Well, we've already done that. The mean is going to be 40. And the standard deviation is going to be the square root of NPQ, which is going to be 50 times 0.8 times 0.2 equals, and square rooted, is going to be 2.83. So just for NPQ, I just subbed in those numbers over there. Okay, now, armed with that, so what are we trying to find? So we have, I'll show you what this kind of looks like now, because it's also not obvious. So the mean, we figured out was 40. So the mean is actually 40. And our experiment was that when we did it, we got 37. So we think that it's probably less than 4. We think that their success rate is probably less than 80%. But we're going to find out this probability to really figure it out for sure. So what we are going to do is, so our null hypothesis is going to be that the mean is 40. We suspect that the mean is probably less than 40. We want to be 90. We want to reject this claim with a confidence of 85%. So the alpha is going to be 15%. So what we want is, we want the probability that x is our experimental result or weirder. So it could be less than or equal to 37. And I kind of ignored the or equals before because it was continuous and it didn't matter. But here it's discrete, so it does matter. And so 36, 37, because we're going to have to do a continuity correction. So 36 is there, 37 is there, 38 is not. So it's going to be cut over there. So this is a discrete probability. And that's going to be equal to the continuous probability that x is less than 37.5. So then we're going to do our z-score, and the z-score is going to be the x value, which is now 37.5, minus the mean, which is 40, divided by the standard deviation, which we figured out before, based on the approximation, was 2.83, right? It's 2.83, and so that's going to give us 2.83 is negative 0.88. So that's like saying, that's like the probability that the z-score is less than negative 0.88. And we're going to look it up on our chart. And that will be 1894. Sounds like a year. Which is 18.94%. So the probability of being there is 18.9%, which 18.94%, which is unusual, but is it like more than 15% unusual? It is not. So, unfortunately, 18.94% is not less than our alpha. So therefore, we cannot reject the claim of Slurm Inc. with a confidence of 85%. So they're probably lying, but I'm not 85% confident that they are indeed lying.